In this fourth lesson of Chapter 3 of the course of Basic Geometry, I presented the method of calculating areas of several types of triangles. I presented in the topics the calculus of the areas of all the types of triangles. In this first slide of this fourth class of Chapter 3 of this course of Basic Geometry, it's presented the figure 3.21, which introduces the concept of the bisector of angle. Bisector of angle is the line segment that originates from a vertex and divides the internal vertex angle in two equal angles. In a triangle, there are three bisector of angles. The meeting point of the three bisector of angle is called Incenter, and it is represented in the figure 3.21 by point I. The circumference whose center is the incenter point is tangent to each of the three sides and is called inscribed circumference. In an equilateral triangle, the points that define incenter, centroid, circumcenter, and the orthocenter coincide. The second slide of this fourth class of Chapter 3 presents the method of calculating the area of an acute triangle. Figure 3.22 presented on the slide shows the triangle ABC. In this triangle, the straight line segment AB is the base of the triangle. The area of a triangle is given by the multiplication of the dimension of its base by the dimension of the segment called the height of the triangle, corresponding to the side of the base divided by 2. In the case of the triangle ABC, the area is given by the product of the dimension of the line segment AB multiplied by the dimension of the segment of the line CD divided by 2. By drawing perpendicular at vertices A and B, and also drawing a segment of the line parallel to the base AB at point C, two additional triangles AEC and CFB are formed. But when looking at the total of the figure, we observe a total rectangle ABEF, composed of the sum of the two rectangles ADCE and BDCF. The area of the rectangle ADCE is given by the product of the dimension of the base formed by the segment AD multiplied by the dimension of the segment of the line of the height CD. The demonstration of the calculation of the area of the acute triangle continues on this slide. As this rectangle ADCE is divided in half by the straight line AC, we can say that the area of the triangle ACD is half the ADCE rectangle area. In this case, the area of this triangle is given by the product of the dimension of the straight line segment AD multiplied by the dimension of the straight line segment CD divided by 2. The BDCF, the rectangle area, is given by the product of the size of the base formed by segment DB multiplied by the dimension of height line segment CD. As this rectangle is divided in half by the straight line CB, it can be said that the area of the triangle BDC is half the area of a rectangle BDCF. In this case, the area of this triangle is given by the product of the dimension of the straight line segment BD multiplied by the straight line segment CD divided by 2. But the area of the triangle ABC is composed of the sum of the areas of the triangle ADC and BDC, that is, the sum of the dimension of the straight line segments AD and BD multiplied by the dimension of the straight line segment of CD, that is the height, divided by 2. This slide shows the method of calculating the area of a right triangle. The figure 3.23 shows a right triangle ABC. In the case of the right triangle, one of the legs has the dimension of the height itself. Thus, the area of a right triangle is given by the multiplication of the dimension of the straight line segment that makes up the base by the dimension of the straight line segment that makes up the height divided by 2. In this last slide of this fourth class of Chapter 3 of the course of Basic Geometry, the method of calculating the area of a obtuse triangle is presented. Figure 3.24 shows the obtuse triangle ABC. The area is given by the dimension of the base composed of the straight line segment AB multiplied by the dimension of the height composed by the straight line segment CD divided by 2. In the case of the obtuse triangle, to draw the straight line segment of the height, it is necessary to extend the straight line segment forming the base, which results in the straight line segment BD. Thus, you have the two triangles BDC and ADC. The area of an obtuse triangle is given by subtracting the area of the triangle BDC from the area of the triangle ADC. Thus, the area of the obtuse triangle will be given by subtracting from the dimension of the straight line segment AD the dimension of the straight line segment BD multiplied by the dimension of the height CD divided by 2. But the subtraction of the dimension of the straight line segment BD from the dimension of the straight line segment AD results in the straight line segment dimension AB. Thus, the area of the obtuse triangle is given by the product of the dimension of the straight line segment that forms the base AB multiplied by the dimension of the straight line segment that forms the CD height divided by 2.